Hello again. In the previous lesson, we worked with trigonometric identities. Now we're going to solve trigonometric equations. Solving trig equations is different from solving regular algebraic equations because trig functions actually repeat. So there may be more than one answer in the interval, but let's begin with the quick rules. Solve trig equations by finding all angles that give the required trig value. Use the reference angle quadrant signs. On 0 to pi, list every solution in that interval. And then for square trig equations, solve carefully and check each solution. The main idea is that you do not stop after one angle. And you need to use the unit circle and find every angle in the interval. Okay. So example number one, it says solve sine x equals a half on the intervals given. State the reference angle in all solutions. So we need all the angles from 0 to 2 pi, not including 2 pi, where sine equals a half. So we need to start with the reference angle. So sine x equals 1/2. So we know that the sine of pi over 6 is equal to 1/2, right? So the sine of pi over 6, 1/2. So the reference angle is essentially pi over 6. Now we need to determine the quadrants. Sine is going to be positive in quadrant number 1 and quadrant number 2. Okay, that's where the y's are positive. So in quadrant 1, the angle is the reference angle. So x is going to be, okay, the reference angle is x is equal to pi over 6. In quadrant 2, the angle is pi minus pi over 6. Okay, so pi minus pi over 6, or 6 pi minus pi over 6, which is the same as 5 pi over 6. Oops, I did not mean to do that. Okay, so x is equal to 5 pi over 6. So the solutions are essentially x is equal to pi over 6 and x is equal to 5 pi over 6. So both angles have a sine equal to 1/2. All right. Example number 2. Solve 2 cosine x plus 1 equals 0 on the intervals given. State the quadrants and all solutions. So first of all, we need to isolate cosine. All right. So we have 2 cosine x plus 1, 0. 2 cosine x equals -1. That's me moving the 1 to both sides, subtracting the 1 on both sides. And then I'm going to divide 2 to both sides here. So that's going to give me cosine x, which equals -1/2. Now find the reference angle. So the reference angle we know is the cosine of pi over 3. So cosine of pi over 3 is going to be equal to 1/2. The cosine at pi over 3 is equal to 1/2. So the reference angle is pi over 3. And cosine is negative in, the cosine would be the x. So the x would be negative in quadrant 2 and quadrant 3. Okay. So again, cosine quadrant 2 and quadrant 3. In quadrant 2, the angle would be, let's see, that would be x equals pi minus pi over 3, the reference angle. That would be 3 pi minus pi over, then x equals 2 pi over 3. And then in quadrant number 3, the angle would be pi plus pi over 3, which would be 3 pi plus pi over 3, which would be 4 pi over 3. So the solutions would be x equals 2 pi over 3 and x equals 4 pi over 3. So those are the two angles in 0 and 2 pi where cosine equals a negative 1/2. Pause and try the problem below. Okay, in this problem, tan x is equal to negative 1 on the intervals given. So first of all, the reference angle is pi over 4, okay? Because we have tan, right? Now, tan at pi over 4 is equal to 1. And I'm getting this based on the parent functions, okay? So that's how I solved example number 1, because I knew the parent function, and then also the second one is as well. All right, and then the quadrant, understanding the quadrants as well, will help you solve those previous problems if you didn't quite get it. Nevertheless, tangent is negative in quadrants 2 and quadrant 4, okay? So the tangent is negative in quadrant 2 and quadrant 4. And the reference angle, since it's pi over 4, so we have x equals pi minus pi over x 4 pi over 4. Okay. And then the angle in quadrant number 4 would be x equals pi plus pi over x, actually 2 pi over 4, so this is 8. So 2 pi over 4 be 8 pi minus pi over 7 over 4. Okay. Now, let's see. So the solutions would be x equals 2 pi over 4 and x equals 7 pi over 4. So tangent equals negative 1 at here and here on the interval for 0 and 2 pi. Let's continue. Example number 3. Solve 2 times sine squared x minus sine x equals 0 on 0, 2 pi. Factor first, then solve all solutions. So this equation has a common factor, and we need to start by factoring out sine x. Okay, so we have 2 sine squared x minus sine x, 0. Then we have sine x, parentheses 2 sine x minus 1 equals 0. Okay, so again, that's me factoring one of the sines out of 2 sine x squared. Okay, and then factoring sine x out of the expression here would give me minus 1. Now we can use the zero product property, okay, which essentially says sine x equal to 0 or 2 sine x minus 1 is equal to 0. And we can solve each equation separately, okay? So sine x equals 0 on the interval 0 to pi. Sine equals 0 at x equals 0, comma pi. Remember, 2 pi is not included because the interval is 0 to pi. So now we have to solve the second equation. So we have 2 sine x minus 1 equals 0. 2 sine x equals 1. Sine x 1/2. We already solved this type of equation, right? Sine is positive in quadrant 1 and quadrant 2, and the reference angle was pi over 6. So we already know that x is equal to pi over 6 and also 5 pi over 6, okay? This is from the previous problem. So all solutions are essentially x is equal to 0, pi over 6, 5 pi over 6, pi. And again, you could put the answer in order from 0 to 2 pi. Okay. Example number 4. Solve cosine parentheses 2x equals a half on the following interval. So this equation is different because the angle inside cosine is 2x, right? This is the angle. So it's the theta is essentially 2x. So what we would do is we would write u is equal to x, okay? Then the equation becomes essentially cosine equals a half, okay? Now, cosine equals 1/2 at following, at u equal to pi over 3 and 5 pi over 3. But because u is equal to 2x and x goes from 0 to 2 pi, u goes from 0 to 4 pi instead, okay? So what that means is, okay? So we need all u values within this. And so essentially where the cosine is going to be a half. So cosine has a period of 2 pi. Okay. Cosine has a period of 2 pi. So essentially what we would do is we would add 2 pi to the first two solutions. So we have u equals pi over 3 and 5 pi over 3. So we would add pi over 3 plus 2 pi. And so let me see. So in order to give a common denominator would be 3. So this would turn to 6 pi. 1 pi plus 6 pi would be 7 pi over 3. And then 5 pi over 3 plus 2 pi would be 11 pi over 3. So the u values are the following: pi over 3, 5 pi over 3, 7 pi over 3, and 11 pi over 3. Now, we need to convert back 2x essentially by dividing each answer by 2. Okay. So if we had, so essentially we would take 2x and set it equal to pi over 3. 2x equals 5 pi over 3. 2x equals 7 pi over 3. 2x equals 11 pi over 3. Okay. And if we set those equal to the values, we would get x equals pi over 6. We would get 5 pi over 6. We would get 7 pi over 6. And then we would get 11 pi over 6. And this again is just setting this equal. So if I did 2x equals pi over 3, that's all that is just simply multiplying by a half. X is equal to pi over 6. So that's essentially what I did to each of these values. Okay. The most common mistake here is forgetting that 2x covers a larger interval. And so that is why we got 4 solutions instead of only 2. What's a common mistake here? A student solves sine x equals root 3 divided by 2 and gives only x equals pi over 3. Explain the following, or explain the missing solution on following intervals. So the student found one correct angle, but not all of them. Sine is positive at the first two quadrants, quadrant 1 and quadrant 2. The reference angle is pi over 3. In quadrant 1, the angle is x is equal to pi over 3. And so in quadrant 2, we would have pi minus pi over 3. That would be 2 pi over 3, because it would end up being 3 pi over 3 minus pi over 3. Okay. So what we would do is we would have this one and we would have 2 pi over 3. So those are the two correct solutions. X is equal to pi over 3 and x is equal to 2 pi over 3. So the missing solution is this one. Okay, so again, they found one. They were actually missing this one right here. So when solving trig equations on the interval 0 to pi, you got to always check the quadrants, okay? Because there may be more than one answer to the solution, okay? So just to review the quick rules: when you're solving trigonometric equations, you want to solve them by finding all the angles that give the required trig value. Use the reference angle and the quadrant signs. On the intervals, you need to list every value. Make sure you double check the graph as well. And then for square trig equations, solve carefully and check each solution. All right. And thank you again for watching.